Hi everyone, welcome to one of our first videos in AP Chemistry, and this is dealing with the scientific problem solving. So I just want to make a quick note while we're here, just so that way you can see kind of like what the format is of our lessons. So essentially, for the first few weeks, we're going to be dealing with the introduction. So this is giving you a background of basic chemistry, and then we have different subtopics. So in this case, this is topic A, it's dealing with chemistry, scientific method, and chemical and physical changes. The number and the name all deals with what specific video in that topic I want you to watch. If you take a look down here, right over here gives us, it says TRO 3rd edition, so that's our textbook, and this is dealing with pages 3 and 4. So I want you to also look at pages 3 and 4 as we're going through this video. So in this lesson we're going to deal with parts of problem solving, talk about what theory is versus a law, and pretty much a quick conclusion. So with all of these notes, I want to make sure that you're not only writing down what's on the screen, but also what I'm saying. So I'll make specific notes on what we're talking about. So for example here, parts of problem solving. So whenever we're solving a problem in any of our sciences, we have to first state what that problem actually is. Then we make observations. So we have quantitative versus qualitative. Quantitative observations are anything that deals with numbers. Qualitative is a visual or something that we feel. So for example, if we want to take the temperature difference of a container of water before and after we've placed a hot piece of metal in there, that is a quantitative observation. If we're feeling the outside of the container and feel that it's actually getting warmer, that's qualitative. So, just like I said before, make sure that you're writing down some notes. You want to make sure you're writing down what I talked about of quantitative versus qualitative. Alright, so back to the notes. After we make those observations, we formulate a hypothesis, and we perform a bunch of experiments to make sure that we can see if we accept or reject a hypothesis. Many times you might want to say that we prove a hypothesis. We are not in any state to prove a hypothesis. That's going to take tons and tons and tons of experiments and research in order to do that. That's a lifetime worth of experiments. Here in class, we can accept or reject a hypothesis. Then we can modify the hypothesis and perform the experiment again and pretty much repeat those steps essentially over and over again. And that's what scientists do. So, two words that people use interchangeably but don't really know what they're talking about are theory and law. So a theory is an explanation of a problem, and we're constantly refining it. So an example of this is the atomic theory, or pretty much what atoms are made of. So we start out all the way at the back of this, which is dealing with the Dalton's atomic theory in 1803. Dalton had said that the atom was pretty much a solid sphere, that there was nothing in it, and it was just a sphere. 100 years later, J.J. Thomson, with new technology, was able to determine that there actually were positive and negative charges embedded inside of an atom. Rutherford, with just a few years later, with some more technology, was actually able to show that no, there's not positive and negative charges everywhere. There's actually a nucleus that has a positive charge and a negative charge surrounding it. The Bohr model, which is what we use a lot of, shows that those electrons are actually in energy levels. And the Schrödinger model, which is the most current model that we know of, shows that those electrons are actually in a cloud, in a space around the nucleus. So the whole point of this is to show you that theories can be changed, right? Especially with advances in technology, and you guys will see a lot of that throughout your entire lives. Laws are actually going to be behaviors that we observe, naturally, right? So nothing that we experiment with, essentially, or that we discover. I don't know how to describe that, but essentially the law of conservation of mass, right? So law of conservation of mass says that if you put two things together and you get something at the end, no matter what, the mass of the two individual things that you've put together will equal the mass of the thing at the end. So we cannot create or destroy matter. That is a law. No matter how many times or how many different experiments we conduct, we will see that we will always conserve mass, meaning that the mass of the reactants beforehand will equal the mass of the products after. So essentially a quick little conclusion, and this is a quick video for today. We have several parts to the scientific method, and this is actually a picture from your textbook as well. So right over here on the right-hand side, We've got theories. We're constantly testing theories with different experiments and confirming or revising our theory. Then we're taking a look over here, observations, which we need to make sure we make a lot of in science. We can use that to help us define our hypothesis or essentially to write out a law. And this is kind of a cycle with experimentation as well. So we're constantly testing experiments or testing a hypothesis in order to confirm whether or not it is valid or invalid. All right, so let me know if you guys have any questions. Take care.